Mm, still in the transformer series, we have a question here. The transformer steps up 200 volts. It has 10 windings in the primary and 100 windings in the secondary. The current in the primary winding is 1.2 amperes. What is the current in the secondary, given that the efficiency is 80%? So before we look at this question, we have two types of transformers. There is a step-up transformer, and then we also have what we call a step-down transformer. So all these two are different, but for a step-up transformer, the number of turns in a step-up transformer for it, the number of windings, or call them turns, in the primary coil. For step-up, number of turns in the primary coil are less than those in the secondary, whereas for a step-down transformer, the number of turns in the primary coil are more than those in the secondary coil. Another name you can give turns is windings, so you can choose to call them turns or windings. So if you have to look at what we are given in the questions, the question says the transformer steps up 200 volts. So meaning that the voltage which is supplied in the primary coil is the 200 volts, which is to be stepped up, because we are saying a transformer steps up 200 volts. So it is supplied with 200 volts, which it steps up. It has 10 windings in the primary. So 10 windings, let me call them number of turns in the primary, being equivalent to 10. And then 100 windings in the secondary, and that means the number of turns in the secondary coil is equivalent to 100. If the current in the primary winding, so the current in the primary winding, I'm going to call it IP, and it is equivalent to 1.2 amperes. What is the current in the secondary, given that the efficiency? So efficiency, I'm going to use this symbol to represent efficiency. So the efficiency is 80%. We all know that efficiency, the formula for efficiency is given by the power output divided by the power input, multiplied by 100%. So this is the formula for efficiency. Another thing, or another formula that we need to know, is the formula for power output, because power out is always out in the secondary coil. So power output is given by the current in the secondary coil multiplied by the voltage in the secondary coil, and then the power, which is input, which I call power in, is got by multiplying the current in the primary coil with the voltage or potential in the primary coil. So with all these, we can go ahead and calculate what they're asking us. They're asking for the current in the secondary, given that the efficiency is 8%. So before we get the current in the secondary, we have to first get the potential, which is in the secondary coil. Potential in the secondary coil, remember we have potential, number of turns. So there is a relation which relates the number of turns in the primary to the number of turns in the secondary. And basically that relation is given by, or it is always written as, if we have the number of turns if we have the potential in the secondary as Vs, and then the potential in the primary as Vp, this should be equivalent to the number of turns in the secondary coil divided by the number of turns in the primary coil. So since we are looking for Vs, which is the potential in the secondary, Vs will be given by, we just multiply the number of turns in the secondary, which is Ns, multiplied by Vp, which is the potential in the primary, divided by number of turns in the primary. So if we go ahead and substitute, since we have the values, this is the number of turns in the secondary is 100. So this will be 100 multiplied by the potential of the primary, which is 200, divided by the number of turns of the primary, which is 10. So we shall end up having our answers as 2000 volts. So this is the potential in the secondary coil. So after getting the potential in the secondary coil, we can now apply this formula here for efficiency to get the current, which is in the secondary coil, since it is lacking. So applying that formula, let's put in or feed in the values. So if we feed in the values which we have, the efficiency is 80%. So we shall have 80% being equivalent to the power output. Power output is current in the secondary, which we don't know. Actually, it's what we are looking for, multiplied by the potential of the secondary. We've got that as 2000, everything divided by power input, which is current in the primary. The current in the primary coil is 1.2 amperes, multiplied by the potential in the primary, which is 200 volts, everything multiplied by 100%. So if you work out this, or if you make IS, which is the current in the secondary, the subject of the formula, we shall end up having 80 multiplied by 1.2 multiplied by 200 divided by 2000 multiplied by 100. So if you calculate this to get the value of IS, please always pay extra attention when dealing with such calculations, because most people they end up pressing values wrongly. Make sure you press the values in the right positions or in the right way. So if you feed this into your calculator, or if you just calculate this by reducing, you'll end up having your answer as 0.096 amperes. So this is the current which is passing in the secondary coil. And remember, the question was asking for current which is passing in the secondary coil, and the answer is 0.096 amperes. So all in all, if you have to look at this type of transformer, because it has 10 windings in the primary and it has 100 in the secondary, so this means that this transformer is a step-up transformer, because the number of turns in the secondary is greater than the number of turns in the primary coil. Otherwise, that's it. Thank you for studying with us.